All right, video 2. I'm first off going to wrap up that last video for us, and I'm going to focus on questions J, K, and L because those have the different format. They gave us a bunch of them where we had to skip count by both numbers to figure it out, but hopefully you recognize as you practice those J, K, and L problems, guys, that you see that J and K are both one of those that we can really get by with only changing one of those numbers. In this case, the LCM for J should be an 8 because I can figure out that 4 times 2 will get me to an 8, and 8 times 1 obviously keeps it an 8. All right, same thing with K. I should be able to determine that 9 is my LCM for K because 3 times 3 will get me to 9, and 9 times 1 will keep that at a 9. So I can actually get by with just changing one fraction. If those were truly my denominators, I could only have to change the denominator with the smaller number and make it into the larger number. That makes my job a little easier. Question L is the other format, is the one where if I skip count by 5 and I skip count by 9, the first time those numbers are going to cross paths is at 45. So my LCM for letter L is the one where we have to multiply those two numbers together. That ends up being the only time they cross paths until we get to a much larger number. Until we get to 90 would be the next time those numbers would cross paths. But for our purposes right there, that's the only way to solve that one. All right, so I'm going to jump ahead here to page 138. And this is the top half of that. And I'm going to be very sporadic. I'm not going to go through any of the decimal problems. We're trying to focus our attention only on fractional questions right now. And I'm going to, first of all, every time we get to a question, I'm going to identify is it adding or subtracting, because that is still a possible situation for those. We need to determine whether we're adding or subtracting. And then the next biggest part, guys, is to make sure we come up with a denominator. And I'm going to focus those problems on finding the least common denominator. Once we get that settled, the math itself shouldn't be extremely hard. So question 6 is a fractional problem. It says, in a frog hopping contest, the frog that hops farthest in 2 hops wins. On the second hop, your frog hops 3/8 of a yard. He hopped a total of 5/16 of a yard. How long was his first hop? So we, again, are looking for a smaller number, right? We're looking to combine the first 2 hops to get to the total. They give us the total. So the question here, if we're looking for just one of the hops, tells me that this should be a subtraction problem when I'm ready to solve it. Now, again, key with subtraction, we need to make sure that we put the larger fraction on top, and since they're telling me that 15/16 is the total, I'm going to suggest that that probably is the top number. That's going to be the biggest number. Unless he jumped backwards on his first jump, which I don't think happened, that's going to be our biggest number. And then the second one, he said he jumped 3/8, or it said he jumped 3/8. So I can't solve this problem as it currently stands, so I've got to go to my finding my common denominator, and then what we practiced in that last video, finding the least common denominator. So I'm going to look at just the numbers 16 and 8. And I'm going to think, well, I could multiply 16 by 8, but I really don't want to do that math. I don't want to end up with a denominator that's, in the 90s or in the hundreds at some point. I don't want to do that. Okay? If I look at this closely, I should be able to determine that 8 is a factor of 16. 8 can go into 16, which means I should be able to get by with only having to change that bottom denominator. This is factor A, or case A, where I can get by with just changing one of those denominators or one of those fractions and leaving the other one alone. So how did I get from 8 to 16? Well, I multiply by 2, and remember when we change the denominator, we must also change the numerator. So this is that extra step that we didn't really talk about in the first video. We were just focusing on making that least common denominator, but now when we're making the equivalent fraction, we have to make sure that we do the same thing to the top of the fraction as we did to the bottom. So if I multiplied by 2 on the bottom, I have to multiply by 2 on the top. So my actual problem then, if I'm getting rid of this original fraction and replacing it with the equivalent 16th, 15/16 minus 6/16 should get me to an answer of 9/16 of a yard. So our answer for this one, again, since it is a story problem, 9/16 of a yard. Okay? Does that make sense? Hopefully that makes sense to everybody. And again, we have a simplest form fraction there. It looks like you could maybe simplify that, but because we found the least common denominator, that is simplest form. Now I'm going to skip over question 7 because it's dealing with decimals, and we're going to jump down to question 8. Diana and James are painting a room together. Diana paints 1/3 of the room and James paints 1/4 of the room. How much of the room have they painted? We could easily add the word total behind it, or together, which means we are going to add these fractions together. So again, we're going to start by setting up the problem. I like to stack my fractions vertically. Just makes it so much easier when I'm creating my equivalents right next to them, and I'm adding and subtracting kind of like I normally would with whole numbers. Again, can't solve this problem until I come up with a common denominator. Well, I look at the smaller one. Can I turn that smaller denominator into the larger? No, I can't. They're one apart from one another. Hopefully that triggers in your mind what I said in the last video. If our denominators are one apart, the only way to create the least common denominator is to multiply the two of them together. So our denominator is going to be 4 times 3, or 12. Remembering now that I have to treat the numerator equally. So how did I get from 3 to 12? I multiplied by the denominator on the opposite fraction, so 3 times 4, treating the same numerator the same. 4 times 1 is 4. How did I get from 4 to 12? I multiplied by 3, the other denominator. Do the same thing to the numerator. 1 times 3 is 3, and then it becomes a relatively simple problem. 4 twelfths plus 3 twelfths gets me to 7 twelfths. And again, in this case, 7 twelfths of the room. Okay, so like I said, once we establish that common denominator, we also again know that this is simplest form because we found the LCM. We found the least common multiple, or the least common denominator. All right, bottom of the page here. I'm only going to do question 10. Question 11, it seems harder than it is. It's actually quite easy, but I just wanted to get you a different way to find that common denominator, which is question 10. A teacher brought some colored beads to class. During class, her students used 1 2/9 bags of beads. The teacher was left with 1 5/6 bags. How many bags of beads did she bring to class? Okay, so we've got how much the students used, we've got how much the teacher was left with. We are trying to go all the way back to the beginning and say how many did she bring to class. We're looking for the total amount of beads. If we're looking for the total, that tells me that this is an adding question. Okay, so I'm going to set this up as an adding problem, and again, adding, the order doesn't matter as much as it does with subtraction. All right, so as I'm looking at this problem here right now, again, cannot solve it as it currently stands. 9 in the denominator, 6 in the denominator. The only rule I have with adding and subtracting fractions originally is I can't solve it till the denominators are the same. Now I could go to plan B and say I'm going to multiply 9 times 6 and get to 54, and it'll get me to an answer. It just might not be the simplest form answer, and it just might not be the easiest answer to work with. So be aware and be cognizant of this, guys. I could do 54, but it's going to mean I've probably got a lot more work to do on the back end. If I skip count by both these numbers, hopefully I recognize that both 6 and 9 have a multiple of 18, and 18 is a lot less than 54. I could also see that 36 goes in there, but 18 is that smallest number. So now I'm going to create my new numerators. How do I get from 6 to 18? Times 3. Same thing on the top. This becomes 15/18. How do I get from 9 to 18? I multiplied by 2. Same thing on the top. This gets me to 4/18. All right, so now I add away. I'm going to add my fractional part first. Gets me to 19/18. Whole numbers gets me to 2. Now hopefully again I recognize, or we recognize here, that something's not quite right with that 19/18. We should probably do something more with that. It's considered an improper fraction at this point. So I'm going to keep my 2 there, but I'm going to ungroup or divide 18 into 19. How many groups of 18 can I pull out of that? I can pull one more group out, and then I'm left with 1 as my remainder, and 18, the denominator stays the same. So 2 plus 1 gets me to 3. 3 and 1/18 should be our answer. Oops, wrong problem. 3 and 1/18 bags. Yep, bags of beads. Had to look at what my label should be. I didn't want to make a mistake on that part. All right, so we've seen all 3 kinds of denominator type questions. The first problem we did, we just changed the 1 fraction. The second one, we multiplied the 2 denominators together and came up with our least common multiple this way. And this way we had to skip count by the 9 and the 6 to find the 18. Again, we can do it the other way, but it's definitely going to make it a little bit harder. All right, so I'm just going to focus now on this, again, a handful of these fractional problems. I'm not going to waste my time with 14. You guys, that's already a common denominator. I'm definitely not going to do that one. So let's go to problem 13. Okay, over on the top over there, you can see we've got 2/3 plus 1 2/9. Okay, now again, you can try to solve it this way. I do like to stack things vertically just to make things a little bit more recognizable as an actual adding problem. I should notice here again, my denominators are not the same, but this is one of those nice ones where I can get by with changing the 3 into a 9 and only having to do one equivalent fraction and not have to do 2. So this should get me to 6/9. Now I can add the fractional piece together. 6/9 plus 2/9 equals 8/9. 1 plus 0 is 1. No regrouping, no going over the top. So 1 8/9 should be our answer for that one. Pretty straightforward. How about question 15? Again, another adding problem. I'm going to come to the inside here to stack this on top. 1/5 plus 1/6. Now, hopefully, again, you're picking up on those little clues as we're looking right away. 5 and 6 are only one number apart. I could skip count by them all the way through, but I should start to recognize right away that if they're one apart, I can just simply multiply those two by each other to get my new denominator, and then I'm simply going to multiply by the other denominator to make my new fraction. So in the case of the 6, I'm going to multiply by 5. That becomes 5/30. In the case of the 5, I'm going to multiply by the 6, which gets me to 6/30. I add 6/30 plus 5/30 gets me to 11/30. And again, I can kind of take it off my mind that is it in simplest form? Yes, it is. It's already in simplest form. All right. One last question I'm going to do with you, and then it'll be your turn to prove it on an exit ticket. So we're going to do question 16 really quickly. I'm going to give ourselves a little bit more room. Scroll up here so I can work on this one. This is another adding problem. Okay, I know I'm not doing a ton of problems with subtracting, but the problems are the same, guys. The biggest key here is making that common denominator. So 2 3/10 plus 3 1/4. All right, so as I look at this, I can't change a 4 into a 10. I can't skip count by 4s and up a 10, so that one's not going to work. I could multiply 4 by 10, but that would get me to a denominator of 40, which is a pretty large number. Hopefully, if I skip count by both these numbers, I can quickly figure out that 20 works as that common denominator. How did I get from 4 to 20? I multiplied by 5. Treat the numerator the same, so 5/20 for that one. How did I get from 10 to 20? I multiplied by 2. Same thing to the numerator. This becomes 6/20. So I'm adding my fraction together first. 11/20. 2 plus 3 equals 5. Already simplest form. 5 and 11/20. All right, I'm going to quickly go just to give you an example of a subtraction problem, okay, just to show you that it's not any different than simply finding that common denominator, guys. Here is 2/3 minus 1/4. Okay, denominators are one apart from each other. Biggest key is to come up with that least common denominator right away. In this case, one apart. Simply multiply by the other denominator. Treat them equally. And my new problem is 8/12 minus 3/12. 5/12. Denominator does not change. Now this again is, we've been going through lessons with fractions for quite a while already, guys. So I kind of rushed through those examples at the end there, but I'm hoping by at this point of the game, you're feeling pretty confident. And if you're not, I'm hoping that you're reaching out to your teacher to get some extra help and some extra tutorials on how to solve these problems, okay? The only one that I really didn't handle at this point, I'm going to try to keep it off the exit ticket for you, is the ungrouping when we are subtracting by mixed numbers. So just be aware of that. I'm probably going to exclude that, but that would be something that we maybe need to practice before we get to the test, or something you can ask to practice with your teacher. All right, thank you guys for your attention. Hope you do well on the exit ticket. If something's not making sense, please make sure you contact your teacher.